Good morning. Welcome back. So last class we completed all the array operations, that is traversal, insertion of an element into an array at a given position, deletion of an element at a given position, and sorting. In sorting we did insertion sort, wherein sorting is nothing but arrange the elements in order. It can be either ascending or descending, and searching for an element, that is whether an element is present in an array or not. And we did linear search and binary search, the difference between the two, merging of two or more arrays, then the array representation, that is two-dimensional array representation in row major and column major, and how to find the memory address of a given element in both row major as well as column major. Hopefully you have understood all that. Now we'll start with advantages of arrays. So what are the advantages? Array. What is an array? Array is a homogeneous set of elements stored under one name, physically present next to one another. That is, it is continuous memory locations wherein all the elements of the array are of same data type and stored under one name, wherein array name points to the first element or the of the array, that is memory location of the first element. So it's a pointer to a first element, that is the location of the first element. If you know the location, then since it is continuous memory locations, you can just traverse the array, and then using subscripts you can directly access the elements of the array. Now advantages. So array is used to represent multiple data items of the same name using single name, that is same type using single name. So if you want to store 50 integers, instead of having 50 different variables, so when I say 50 different variables, no two variables can have the same name. So you need to think of 50 different. If it is only 50, like suppose if I want to have 100, then you need to have 100 different variables, right? Instead of that, you can have one array with one name and which can store 50 or 100, how many ever variables you want of the same data type. That is, it is a homogeneous set of elements. You cannot have elements of the different data type, but you can have any number of elements in an array of the same type. So instead of naming that many variables, you can have one array with one name with that many elements. So it is easier to remember, to create, to access. It is used to implement other data structures like stacks, queues, trees, graphs, etc. Like you have linked list based implementation as well as array based implementation. So all these like stacks, queues, trees and graphs. Trees and graphs are non-linear data structures, whereas stacks and queues are linear data structures. You can use array to implement those because these have two kinds of implementation. One is linked list based implementation, which is dynamic, and then array based implementation, which is a static one. Like array is static structure, so you can have array based implementation, and in our course we will be doing array based implementation of these. Then two-dimensional arrays are used to represent matrices because matrix has row and column. So if you want to perform matrix operations, you can have two-dimensional arrays. One is the row dimension, the other one is the column. Then many databases include one-dimensional arrays whose elements are records. Like, yeah, databases is which wherein data, large amounts of data are stored, and you can have one-dimensional arrays to record those elements. And it is also used for sorting elements, CPU scheduling, representation of polynomials, and then data can be accessed faster using subscripts. Yeah. So, and it is very simple to implement. You don't need more of programming, much of programming here. It is easy to use and implement. It is simple. Yeah, please go through this. So, advantages you would have understood. Now we'll go to the disadvantages of an array. That is, one of the disadvantages, you must know in advance how many elements are to be stored in an array, because the array structure is a static structure. That is, the memory is allocated during compilation time only. So even beforehand you should know how many elements you are going to store in an array, otherwise the array memory would get wasted, right? It's a static structure. During compilation time only the size of the array is fixed, that is, that many bytes of memory would be allocated for an array. So if you allocate memory more than required, that is, you are going to store only 100 elements and you have allocated memory to store 1000 elements, then that many bytes of memory would get wasted, because it cannot be allocated to any other programming element during runtime. That is, you cannot allocate or deallocate array memory during runtime, and you cannot even change the size of the array. That is, you cannot decrease or increase the size of the array during runtime. Getting it? Because it's a static data structure. Static structures are something wherein the memory is allocated during compilation time only, that is, before the execution of the program, and which cannot be changed during the execution of the program. The elements of this array are stored in consecutive memory locations, that is, one next to another. So insertion and deletion, we have done both, are difficult and time consuming. Why is it time consuming? Suppose I have an array of 1000 elements and I want to insert a new element in the second position. So for that you need to push in all other 998 elements, right? And then only you can insert. So it is more time consuming, it takes more time, and it is difficult to implement. The same thing applies for deletion also. So it is more time consuming and difficult. Please go through this. By this we come to an end of arrays, and we will be starting stacks, which is again another linear data. So we completed with arrays, the advantages and disadvantages of arrays. Hopefully you have understood that. Now we'll start with stacks. So what is a stack? A stack is a linear data structure which follows a particular order in which the operations are performed. So what is a data structure? A data structure is a way of storing data elements in computer memory. There are two types of data structures. One is linear and non-linear data structures. So what does linear data structures do? Linear data structures store data in sequential manner, and arrays and stack are common linear data structure. But the main difference between an array and stack is array stores elements of the same type, while stack stores elements of the different types. Fine. So both are linear data structures only. So that is, the linear data structures store data in sequential manner. So difference between an array and a stack, the main ones are: array is a data structure containing elements, that is, the collection of elements which can be identified by an index. Yes, we know what is an index or a subscript. Each element in an array can be identified by an index or a subscript value, whereas a stack is an abstract data type that serves as a collection of elements with two principal operations, that is push and pop. What is push? The insertion or adding or inserting an element into a stack is called push. Push is nothing but pushing in an element into a stack, whereas deletion, extraction of an element, that is deletion of an element from a stack, is called pop. Push and pop are the operations of stack, and then there's a particular order or a method in which these operations has to be performed, right? We can implement stack in any programming language, like I can use implement data structures using C language, C++, Java, but the operation, the way, the order in which it is performed is same, and you need to follow that order only when I'm doing push or pop operation. And then array contains the element of the same type, whereas stack contains the element of different data types. The basic operations on arrays are insert, delete, modify, traverse, sort, search, merge. All these operations we have already done, right? These are some of the operations performed in arrays, whereas basic operations on stack are push, pop, and peek. The any element in an array can be accessed using array index. Yes, I want to access the third element directly, I can access. It allows the random access. I don't have to go from 1, 2, 3, 4. Directly I can access that, whereas in stack only the topmost element, that is, it follows the last in first out order. That is, the last element inserted would be the first element deleted. For example, I have 5 elements in my stack. Then in order to delete the first one, I should delete the fifth one, fourth one, third, second, and then only I can delete the first. I cannot directly delete the first, whereas in an array I can delete any element at any location. It need not be like I have to delete the previous elements. We have done that also, right? So in real life, for example, a real life explanation of stack can be a stack of plates. So if you have a stack of plates, the plate on the topmost would be the first to go, right? The topmost plate would be the last plate to be kept. It will be the first plate to go, and the last plate, that is the bottom plate, would be the first plate would be the last plate, because the bottom one would be kept first, but it will be the last plate wherein people will pick it. Because from the top, when you go on picking, you will encounter the first plate which was kept in the end. That is, the first in the is the last to go out. First element would be there in the stack for the maximum period of time. Hopefully I'm making some sense. Definitely it will take some time to understand. Please do attend my other classes, like another tomorrow's and day after tomorrow's class. You will be able to understand it in a better way. Okay, and then we'll see, like, see, for example, this is a stack and I have elements 1, 2, 3, 4, 5 stored in that. Top is a pointer which points to the last element which was pushed in, which will be the first element to go, right? 5 is the last, because first I would have pushed in 1, 2, 3, 4, and 5 would be the last element pushed in, would be the first element to go out or delete. That is the last in, first out principle. The insertion and deletion happens from only one end, that is the top end. Please have a look, try to understand. I will write an example and show you how to perform the push operation. When we do push operation, you will I will show you how to do it. Then it will be easy for you to write the algorithm and the program. So what you have to check, when I am doing push, I should check whether there is space left in the stack or not, because if I am trying to push in a new element into an already full stack, it should give me the overflow or stack full condition. And if I'm trying to delete from an empty stack or pop out an element from an empty stack, it should be able to give me the underflow condition. So I'll tell you what is overflow, what is underflow when I show you exactly how it works. But it will just remember that last in, first out. That is, the element which was pushed in or put into the stack in the end would be the first element deleted. Please have a look. Then you can have stack. Stack can be implemented in two ways. One is array based implementation or using arrays, which is static implementation. What do you mean by static implementation? The memory would be allocated during compilation time before the execution of the program. So the memory allocated would be fixed. You cannot increase or decrease it, whereas dynamic implementation is nothing but the memory allocated during the execution of a program. So that is dynamic implementation, and you can see linked list over here wherein each one is logically next connected to one another, whereas in an array the elements are physically stored next to one another. That is, it is continuous memory blocks wherein the elements would be stored in an array, whereas in a linked list it need not be. Each one is called a node, and nodes need not be one next to another, but they are logically linked to one another. How exactly it happens when we do linked list, I'll tell you how to create a node dynamically by allocating memory during runtime, and how I can delete and deallocate memory during runtime. So we will be studying the array based implementation, that is stack implemented using arrays for our exam. It's a very important question. Please go through that. And one of the other ways of like why I need stack would be, say for example, if you're executing a program, the program execution, the main function gets loaded in main memory and it's a sequential execution. So if there is a function call, so where should it return? Like function call return, function return pointer, like after the execution of the function, where it should start executing from, that is stored in stack. And the value of static variables would be stored, or the expressions when you are evaluating big expressions, then the intermediate results, like not the final output but the intermediate results, can be stored in stack. Or the local variables, are the variables which is created in the function, which are local to the function. As long as the function is executing, that variables would be there. Once the control goes out of it, it gets destroyed. So those variables can be created in stacks. Like stacks can be used in number of ways. Please have a look. Then we'll start with the push function. I'll just take an example and tell you how exactly the push operation is done, what you have to look for, and then when I write the algorithm, it will be easy for you to understand. So now we'll consider a example. For example, this is a empty stack. Fine. The memory representation of a stack. So how many elements can I see here? S of 0, 1, 2, 3, 4, 5, 6, 7. So it will be totally 8. So S is an array of 8 elements, right? S is an array of 8 elements. So what is n value here? The number of elements is 8. Okay. And then top is a pointer which points to the latest element, that is the last element pushed in into the stack. Since there are no elements here, the stack is empty. When the stack is empty, top would be, what is the value of top? Top would be -1. Why is top -1 when it is empty? Because if I say it is 0, then S of 0, some element should be there in that location, right? That is why when the stack is empty, so when there are no elements, then it is -1. N is the total number of elements. Total number of elements is 0 to n minus 1. That is 0 to 7 is 8. So S is an array of 8 elements. Now I will start the push operation. So push What is push operation? So let me say push is nothing but inserting an element into a stack. So push, let me say first one, I will say push 88. I want to push an element 88. Okay. So what should be the first thing I should be doing? First I should check for the overflow condition. Whenever I am doing push, first I have to check for the stack full or overflow condition. What do you mean by that? I have to check whether there is any place in the stack or not to add a new element into it, because it's a fixed. We are doing array based implementation, so it happens during compilation time. When I say size is 8, I cannot increase the size of it. Maximum at any given point of time, the maximum elements it can have is 8. Minimum can be 0. Like you don't have any elements, it becomes an empty stack. But the maximum elements I can store is 8. I cannot exceed more than 8 elements. I cannot push in more than 8 elements into the stack until I pop out one. If I delete one, then I can push in a new element. So for example, I'll say push 88. So what should I do? First I should check for the overflow condition. What do you mean by overflow condition? I need to check for the overflow condition. How do I do that? I need to say what is top. Top is a pointer which points to the element which was last pushed in. So if top is equal to n minus 1, which means that there are no elements in the stack. What is n minus 1? 7. So if I have to push in into this location, I should have pushed in into all these locations. That is, if I want to have an element at S of 7, then I cannot leave S of 0, 1, 2, 3, 4, 5 and 6 vacant. It has to be filled, then only I can fill the 7th, that is the 8th element in position S of 7. Getting it? That's the order which you have to maintain. It is not like an array wherein I can enter S of 7 value without entering all these values. But then in stack, in the push operation, the first element always goes down, which is goes to the S of 0, then S of 1, 2, 3, 4, 5, 6 and 7. So if I have top in S of 7, it means that the bottom ones would be filled. There is no place in the stack to insert a new element, because the size of my stack is 8 elements. So 0 to 7 is 8. So I don't have any place to push in a new element, right? So that is what I mean to say. Push 28. So check for overflow condition. How do I check for overflow condition? Check if top is equal to n minus 1. So this n, make it in lowercase only because n is 8. So check if it is top is n minus 1. So what is top? Top is -1 and 7. So not equal, right? Then what should I do? See, if it is not equal, first I have to make top point to this location and then only I have to insert. At present, top is pointing to null. It is equal to -1. It is not pointing to this location. For that reason, first I have to make top plus plus. So which is nothing but -1 plus 1 is equal to 0. So now top is equal to 0 and then s of top, everywhere top is lowercase only. Please make it as lowercase, don't make it as. When I write the program, it will be, I will take care of the case. Here top means top only. Okay, please make sure of that. S of top is equal to, what is S of top? S of 0 is equal to, I wanted to push 88. I'm pushing 88 there. So what happens here? Top is pointing here. Okay, and it is 88. I have pushed in because I said S of top, which is nothing but S of 0, because top is 0, 88. So where is top pointing now? It is pointing to the last element pushed in. Which was the latest element pushed in? It was 88 and top is pointing there. Now I want to push in one more element. Let me push in 7. Okay. So what should I do? Check for the overflow condition. So check if top is equal to n minus 1. That is, what was top? 0. And what was n minus 1? 7. Not equal. So I can do what? I have to increment top first. Why should I do it? Because see, top is pointing to this location. If I say yes of top is equal to whatever new value, then it gets rewritten on that. So what is the procedure? I should make it point to here, a vacant place, and then I need to insert it, correct? That should be the step. So I should say top plus plus, which is nothing but, what was top? 0 plus 1, which is 1. Top is 1. Then I will say yes of top is nothing but yes of 1 is equal to 7. Because I wanted to push 7 there, I have pushed it. Excuse me. So top was pointing here. When I said top plus plus, it came here and then I'm pushing in 7. So which was the latest element pushed in? 7. So now top is pointing there. 88 is the first, which was the first element pushed? 88. The latest element is 7 pushed in. So when I pop, first 7 has to be deleted and then only I can delete 88. Getting it? First in, first out. First in, last out, or last in, first out. Next, I will show you till the overflow condition. Next, I want to push 90. Okay, I want to push an element 90. What I have to do? I have to check for the overflow condition. Check if top is equal to n minus 1. So what is top? Top was 1, right? So it is 1 and 7, not equal. So they are not equal. It means that there is still place in my stack. So increment top first, which is nothing but, what was top? 1 plus 1, which is equal to 2. Top becomes 2 here, and then yes of top is equal to yes of 2 is equal to 90, because I want to push in an element 90 there. So what happens here? Top plus plus will make top point to 2. So it will be pointing here And then yes of top is nothing but yes of 2, and I'm putting in 90. So the latest element inserted was 90 and top is pointing there. I hope you're getting it, how the push operation is working. Then I want to insert one more element. So let me say push 77. Okay. So what was the procedure? Check if check for the overflow condition. So what is that? A top is equal to n minus 1. So what was top? Top was 2. So 2 and 7 not equal. So when it is not equal, what can I do? I can insert, right? When 2 and 7 are not equal, so first I have to increment top because it has to move to a vacant location. First, what was top? It was 2 plus 1, which is 3. And then I say yes of top, which is nothing but yes of 3, which is equal to, I want to push in 77, I will push in 77 over there. So first I need to increment top. So let me increment it here and I will say 77. So which was the last element pushed in? The last element pushed in was 77 and top is a pointer which is pointing to that one. And when top is not equal to n minus 1, I can see still I have 4 more places, that is 4 more elements can be pushed in until my stack becomes full. Getting it? Until my stack reaches the overflow condition. So let me insert one more element. So for example, push 0. I want to insert 0. Again the procedure is same. Check for the overflow condition. So check if top is equal to n minus 1. So what is the top value here? 3. 3 and 7 not equal. So I can say first I have to increment top, which is nothing but 3 plus 1, which is equal to 4. So yes of top, which is yes of 4 is equal to 0 because I want to push in that. So go back here. First what happened? Top is pointing to this location. If I do S of top here, then on 77 0 gets overwritten. First I have to increment it to a location where there is no value. Then I will insert 0. So 0 is the last element inserted and top is pointing to that location, right? So let me insert or push in one more value over here. So push 1. I want to push 1 here. So how will I do that? First I have to check for the overflow condition. So check for overflow condition is nothing but check if top is equal to n minus 1. So what is top over there? Top is 4 and 7. Okay, not equal. So where is top pointing now? It is pointing to the location 4, right? Now I need to first increment top plus plus, which is nothing but 4 plus 1, which is equal to 5. Then yes of top is equal to yes of 5, which is equal to, what was I wanted to push? I wanted to push 1. So it is 1. So what did I do here? Top is pointing to this, right? So I'll make top point here and then I said yes of 5 is equal to 1. So 1 was the last element which is pushed in and top is pointing there. Then I will go back, then I will push in one more element. So I'll say push 78. I want to push in 78. So the same procedure, check for overflow condition, check if top is equal to n minus 1. So what is n here? Top is 5 and 7. So they are not equal. What I should do? First I should make it point to the next location, right? Otherwise it will get overwritten, which is nothing but 5 plus 1, which is 6, and yes of top, which is nothing but yes of 6, is equal to what I want to push. I want to push 78 over there. So what happens over here? Top is pointing here. If I write directly s of top, it gets overwritten. So first I should increment it, right? So top is pointing here, and then I am pushing in 78 at this location. So 78 was the last element which was pushed in. So top is pointing there. Getting it? How the top is used to push in elements. So if you understand this, pop is also very easy to understand. Getting it? Then I want to push in. I'll say I want to push 99. So the same procedure, check for the overflow condition. Whenever I am doing push, I have to check for overflow if top is equal to n minus 1. So what is top? Top is 6, right? 6 and 7. They are not equal. So first I have to increment top, that is 6 plus 1, which is equal to 7. Yes of top is equal to yes of 7, which is equal to 99. So let me do that over here. Yeah, top was pointing to the last element, which was 78. Now I wanted to insert one more. So top is pointing here and I am inserting 99. So top is pointing to the element which was last inserted, right? Then what will I do? I want to insert one more element. So let me say push 88. Okay, I want to insert one more element. You have to check for the overflow condition. CHACK. Check if top is equal to n minus 1. So what was top? 7 and 7. When both are equal, as you have seen, there is no place in the stack until you pop out an element. So I have to say print stack full overflow, right? Stack full overflow, and you will exit. By the time there is no place in your stack, you know top is pointing to this element. This is the last element inserted, and when you are popping out, if I want to pop out one, first I need to pop out 99, 78. Then only I can pop out one. That is, last inserted element would be the first element popped out. Last in, first out. This is how the stack works. Hopefully you have understood the push operation. Push is nothing but inserting an element into the stack. When you are inserting, you have to check. Top is a pointer which points to the last element inserted in. Before above top, you will have no elements over there. The insertion and deletion happens from only one end, that is the top end. So how will you check for the overflow condition? Overflow is nothing but when you are trying to insert an element into an already full stack. That is stack full, you cannot insert a new element. That is stack overflow. That happens, that you have to check for push operation. Push is nothing but inserting an element into the stack. How do I do that? I have to check whether top is equal to n minus 1 because 0 to n minus 1 is n elements. If they are equal, it means that there is no place in your stack and stack overflow condition. Otherwise, top would be pointing to the last element inserted. So you have to make it point to the next location. So top plus plus and yes of top will allow you to insert the element, and again top would point to the last element inserted or the newest element inserted. This is how it works. So in tomorrow's class, we will be writing an algorithm as well as a program about this. Hope you have understood the push operation so that when we write the algorithm, it will be easy for you. So take care, stay safe, see you tomorrow. Bye-bye.